company called DPACE, and we've got a number of shareholders now, including my brothers and some of the key employees, and as you mentioned, a 50% partner from New Zealand. So I'll talk a little bit about our history so you know a little bit about us. We were started in 1995. My wife got a job as the first city planner in Nelson. I was just finishing my PhD and I wanted to live with her, of course, you know. So that's actually what got me into business. I went there and I had been working with a company called UBCO, which had a technology transfer from Triumph, one of Canada's major particle accelerator labs at UBC. And now they're called Advanced Cyclotron Systems, but they were in the very first part of technology transfer to make cyclotrons, a type of accelerator for radioisotope tracers for nuclear medicine. And so I was finishing up my PhD and I asked whether I could work as a telecommuter from Nelson, and the internet was just sort of good enough that I could do that at that time. And they said no, not as an employee. They didn't want to set that precedent, so I had to start a company. And we did that together, the only urban planning and accelerator company. But anyways, now it's strictly accelerators. But anyhow, where did we go from there? So the next thing, it's funny, the little things that nudge you along. Maybe a little bit like you said, Brad. I think I am an entrepreneur, but I didn't really know it, for a while, and eventually realize it. And so one of the next things was our accountant going, well, you can't have one customer. You're going to be taxed like an employee. And okay, I better get another customer. And so in addition to UBCO, worked with Triumph, and then started to go around the globe. And so we mostly design things for other companies for quite a while, and I was trying to look at different ways to grow, and it's a little bit hard. It's a hardware kind of oriented company. You need quite a bit of money to develop products and stuff for hardware, and especially with particle accelerators. And for a few tens of thousands, we could make some little detectors, so we started with things like that. But sort of about 2013, and I tried different things, talked to different venture capital people and different ways. And actually one of the neat things that actually helped is I talked to a fellow in Nelson who had become quite wealthy in the mining sector, and just asked him for some advice at lunch, and he said to hold an advisory board meeting. So we actually flew people from around the world, like one of the, a big cyclotron company in Belgium. It's a $1 billion company. It was kind of interesting. Brought those people to Nelson, Triumph Labs, different, and they had this idea that probably the best thing would be if this Buckley Systems from New Zealand, who was making most of the equipment we were designing for other people, if they bought into us and seeded some money into there. So that's what happened. They bought into us, and the money didn't go to us as owners. It was cash into the company, and then there was a plan, an R&D plan for developing new products, but also with some business and sales goals. And so every year, if we met those goals, we got more cash injection. So it was kind of a neat way to encourage us to really do what we said we would do. And you'll see a little bit about that in a moment. So maybe I'll go on to the next thing here. Whoops. So one little aside, again, I think part of tonight is just to give some tips and little slices of things that we've learned. So we develop about 50% of our technology as our own, and 50% we license from labs, and then further improve it. And one of the neat things that I like about, well, first of all, I wanted to mention there's a connection between sales and R&D. So I think earlier in my life, I maybe didn't have a great opinion of marketing salespeople or whatever. And then it's a big part of my job now, and I realize that it's actually quite connected to the R&D role. And so I really love it because I get to go around the world to hundreds of labs, multinational, small companies, universities, and see what they're doing. It's all confidentiality agreements, and so I can't spread it and tell you details about it, but it's fascinating for me as a technical person, and then I get to see what the problems are in the industry or for individual companies, and our R&D projects will lead to new products, and so that ties into our marketing and sales. And then I realize that even our students, we've got PhD students that are working on things that we hope will come to products in 4 or 5 years. And and their papers, their technical publications are important. It's starting to create an aura of, hey, these people are really good experts in certain areas, and that's a kind of marketing, even though we're doing technical publications. And there's trade show booths, and there's all those sorts of things, meeting customers and whatnot. But anyways, I quite like it now, and it's actually, in a way, the fun part of physics. It's all the figuring out the solving of problems and whatever, and for me that's fun. And then of course there's the technical details and a lot of work to make it happen. It's a kind of a strong relationship type of business. It's person to person, and it's quite, I would say, truthful. Like it's high tech type stuff, and either the specs work or they don't. There's no spin or anything for the most part. And the other thing I find is that there's great cooperation even between the competitors. Like, we'll meet at conferences, have lunch together, share a certain amount of information. It's quite collegial, and I think part of it's because we often end up working together at times. It's that kind of industry. A couple things about agreements. Many of the universities don't have agreements in place yet. Maybe they haven't done a technology transfer before. So we have our own. Other things to appreciate is the labs think differently. They have different mandates. They might not have a mechanism to give you a quote. Let's say they need to help you want them to help you with something. So that could be a big deal. That could take them months to figure that out. And so, some patience there. But you can get some big help from them. Like they could save you 20 years of R&D or something like that. So there's some real pluses too, of course. And one of the other kind of neat things, it's not like working with another company. The professors and students are publishing, so that's how they push forward their careers. So there's some knowledge going out that way, and also you have scientists from around the world doing experiments at all the different universities and labs back and forth. So if you do licensing something from a university, it's there could be some leaking of the technology, but you've got to weigh that up. It still could be an overall advantage for you to be involved with that. And I also like to say it doesn't stop there. It's not like we're just using their idea. We continue to make the equipment. So here you can see, so on the left are sort of the university devices. They're probably doing something to a very high, sophisticated, constraint or specification, but it can look a little homemade. And so part of this, what we do is, of course, is an aesthetic side to it for sales, and also often a reliability and robustness side to it. And also we might be even advancing the specs. We will, the R&D continues. We're continuing with our own R&D. So it's not that we're just copying. And the other thing I'd like to say is we're really proud of paying royalties and whatnot to particularly the Canadian institutions, but also around the world where we license technology. So with that, going back to that New Zealand Buckley's buy-in, and this was a thing we tried to do within Canada, as I proposed to some local colleges and whatnot to make an ion source test facility, and I said we're going to be able to have PhD projects, develop products and masters, and even technical projects, like even at the level of, let's say at Selkirk College, welders and electricians could work with it and so forth. And we applied for funding. This is about 12 years ago. And we had MOUs from Triumph and from other places around Canada and Lawrence Berkeley Lab and things like that. And we didn't get the funding. And ultimately, we did it through the private sector, through this investment from Buckley's. And it's doing exactly what we said it would. We've got PhD students coming through. And that whole device, that's an ion source system over there on the left. And that's a system that we now sell. It was our prototype. We were proving we could do it. We sell those for about $1 million a piece now, and that's part of our growth. And a lot of the bits and pieces of that system are also products. That's this long list over here. So that was a neat thing that sort of sprung out of that investment. And now that we've made that prototype, we didn't want to just junk it. So that's why we now use it as a test bed and are starting to develop other technologies. And then I'm going to quickly just talk about some of the industries. People might wonder, what are particle accelerators used for? Well, that's for medicine. So even here in Kelowna, you would have, if you're having cancer treatments, electron linacs, linear accelerators that either directly treat you with electrons, or they'll hit a foil and X-rays or gamma rays will come out to treat the cancer. There are a lot of those. There's other things called carbon therapy, proton therapy. There's something called boron neutron capture therapy we're involved with. Then the biggest one is number 2, actually, which is related to this. So ion implanters, there's probably, to now, like something like 25,000 ion implanters. And these are nowadays about the size of this whole middle section here. So that's the size of the accelerator. It's like a clean room. It's in a housing. And at the end of it will be, this is a wafer. This is the heart of 50 computer chips here. And this could be 1,000 computer chips. It just depends on the size of the chip. And so to make a computer chip, you have to embed ions, implant ions into the silicon at different depths. And there's a whole recipe of different ions, different depths, and there's lithography, and you've got to cut these chips up and all kinds of things. And so big companies, billion-dollar companies like Applied Materials and Excelis and Sumitomo Ionic Technologies, and we're building one of their next-generation systems in little old Nelson, BC right now, and AIBT out of Taiwan. So they're billion-dollar companies making the equipment that are called ion implanters that they sell to Apple, Intel, Samsung, so forth to make their chips. So these accelerators, hundreds of them, will fill a fab. If you've heard the word a fab, it's gone up in Taiwan for Apple to make chips. That's a building full of particle accelerators with these at the end, and they get embedded. And if you look closely at it, you would see 50 squares there of these chips. So that's one of the big industries that we're connected to. Industrial electron beam accelerators, you can vulcanizing tires, sterilizing medical equipment. And then, of course, the more obvious one that people know, discovery science. So there's big labs like CERN. You know, right now the biggest accelerator in the world, 27 kilometers around, partially under France and Switzerland in the Geneva area. And there's about 1,000 universities with smaller accelerators for things like carbon dating and other things. And there's a couple other ones. When I'm talking about these revenue ones, this is more for the Buckley Systems, the company that's bought into. They're quite tied into the ion implantation side. DPACE, our company, is more a third. But anyways, my role now, I was the founder of DPACE, but I'm what's called the Chief Science and Innovation Officer of both Buckley's and DPACE. And I'm kind of leveraging our 2 client lists. Like DPACE actually had a lot more customers. We've got a couple hundred customers and NDAs with all of them. And we're introducing Buckley's to those customers. And Buckley's has fewer, but it's really tough, as Camille was saying, to enter into the ion implantation. Top secret, very, very strict and tough kind of confidentiality agreements. And they don't want to give anything away. So the first meetings you go in and you're talking to them, we at DPACE, we do this, we can make this and design this, or do research into that, and it's all, and so it's a long process. Eventually I had a beer with somebody after, and then we talked a bit more, and they mentioned that they had a problem. So, I threw a PhD project on it. So that just tells you the time scale. So that's like 4 or 5 years later that something's going to come out of it. And so, but that goodwill was there. Oh, okay. And that's a public domain thing, and they like everything top secret. So I won't say it has anything to do with you. We're just doing it. We're just saying generally, the semicon sector is interested in this, and we're going to do a PhD on it, but it's for you. And so they've kind of warmed up to us, and I'm really excited to say that some of our ion sources, so the things that shoot the initial ions, are being built into ion implanters now through this introduction from Buckley's, which I'm very thankful for. And it's been, again, a long, long process of jumping through hoops, and I could tell you all kinds of stories. Sumitomo in Japan's the same thing. And then, like Brad was saying, there's a lot of travel. So I've done 16 international business trips this year, and a lot of that's conferences, but individual customer visits and connecting with people. One of the other things I just want to say, so one's kind of interesting. This could be in Kelowna Hospital, kind of a scanner on the medical side. Buckley's has done 2,000 of the magnets that have gone into these. This is from the Belgian company that I mentioned. We sell an ion source into theirs. This is for radioisotope tracers for nuclear medicine, for medical imaging to find your cancer. And Actually, this is back to the iron implantation side. This one is really cool. Oh, by the way, over there, that the man in the white there, or woman, I'm not sure, that connection, or sorry, that box holds 25 of these. So a robotic arm comes and grabs each one of these out, unpackages it, puts it into the beam. So there's several pods of those there, and they're full of magnets and other accelerator equipment. This here is a 35-ton magnet made to implant flat panel displays like are up there, but great big ones. The beam here, you can see, is about 2 meters high, so the particle beam's that high. It goes around the corner, and Buckley's can make one of those a week. So they've sold 50 a year basically. And one of the things is that we're really focusing on to compete against countries where they have a labor cost advantage, is that we design our equipment together with the end clients using our physics and engineering expertise and the R&D that we're doing to make sure that they link with us, and then we'll manufacture their equipment for them. So, we're starting to make this sort of equipment in Nelson now. The machining is actually happening in New Zealand, but the assembly of the systems are starting to happen in Nelson. Let me see. This is just quickly national labs I've talked about. Universities do carbon dating type things, and I was pleased to say that the fourth-year business students did a capstone project today where they're looking at a business idea that I've had related to carbon dating. And it's a small accelerator, kind of like that one, that could probably fit up here on the stage. And they did a really good job of assessing whether there's a business opportunity there. And then lastly, just to sort of tie in with the international aspects of it, so now in Auckland, through our test facility, part of the way we connect with the industry is, again, a lot through conferences, attending by presenting technical papers. We usually have a booth as well. We'll give talks like this, actually, on tech transfer and things. And then now we're actually hosting the conference. We've won this. We won it at the last conference for negative ion beams and sources, which was in Novosibirsk, Russia, right in the middle of Russia. And it's a great way to connect, and I hope to bring these sorts of conferences to Canada as well. And we're looking to hopefully link with places like UBCO and Selkirk College to make a more advanced ion source test facility in Canada as well, to complement what we have in New Zealand. So, okay, that's my chat, so thanks.